Well, with that, we can move over into our instruction set where I'm going to be showcasing the DOTS combat system. So this is a combat system that I've used in a bunch of different projects. So I can go ahead and bring this up here and show you the little scene that I have here. So anyways, just to kind of give you just a little bit of a background on the combat system that I've used. By the way, I want to give a quick shout out to Luke Clemens, who's been in the chat. We kind of went back and forth in Discord a while back, and he kind of got me started about thinking about how to set up this combat system in kind of a data-oriented manner. And I think he kind of provided some good references to get me learning about things and just thinking about these problems in interesting ways. And I do think that it came together really well. The multiple times that I've had to implement this, I really enjoy working with it. It does require a lot of setup, as you'll see that there are like a lot of different scripts and components and systems that are all needed to get this to work. But everything is completely separate, so everything works kind of independently, and so this makes it really easy to just easily add and remove features. And once it's all set up, then your designers, you can really empower your designers to do some really cool stuff without adding any extra code and complexity in there. So I'm really happy with this system for many reasons. And so yeah, anyways, I can kind of show you what this little sample project that I got going on here is. So basically what I have here is we have just a little guy that we can move around, and then you can see that we just kind of have like a couple little target enemies around here for us to basically target. So anyways, the first thing that we want to do is actually go ahead and spawn some these capabilities, or what I call them. I call them capabilities because they can kind of do a bunch of different things. So, the first thing that we're going to be showcasing is that it can be used as like an attack, but we can also see that it could be used as maybe like a potion, or maybe you could power your player up. So it's really, there's really a lot of options that we can do for that sense. So anyways, it looks like I do already have it set up to where when I press the space bar, it's just going to go ahead and spawn one of these capabilities off into the world. And then I'm going to show you how we can kind of like build this up and do some cool things with it as we go. So to showcase kind of how I have this set up, so we have the player here, and scrolling down, so this again is the whole hit points. It's the exact same damage system that I went into 2 weeks ago. I didn't make any changes to this damage system. Everything completely builds off of this, and it all integrates with it, and I'll be showing you how that all works here. So again, I would recommend go checking out that video, but it doesn't necessarily need to be a prerequisite learning for this. So anyways, scrolling down, you see that I have this capability prefab authoring here. So all this really is just a prefab reference to this normal projectile prefab that we have here. And so we can click on this and just kind of see what this projectile prefab is here. You can see it's just a basic sphere mesh with a mesh renderer. It has a physics shape. Important thing is that the collision response is set to raise trigger events. I found that this works best for most of the attacks that I have done in my games, because if you use collide, then you start kind of fighting with the physics system a little bit, where maybe even if you do want some collisions to happen where things bounce off of other things, it's better in my experience, or it's easier in my experience to just kind of do that stuff manually, as opposed to using Unity's collision, and then again you having to fight with that when people are trying to move in different ways. I've found it easier to work with just by using trigger events rather than collision events. So anyways, you want to make sure it's set to raise trigger events, so we can basically listen for those trigger events in a system to actually trigger behavior in the game. You'll see that I have the collision filters here. Oops. Basically, we just have kind of different layers for the ground, raycasts, characters, and capabilities. So you can see that it belongs to the capability layer, and it collides with characters, just so we're just ignoring collisions with other things right now for the time being. And then we have this set to a kinematic physics body. And then the only thing that we have on here is this capability authoring. So I'll go ahead and open this capability authoring and basically show you what I have going here. You can see that I was typing in the quaternion look rotation safe to get a little reference to that on there. Anyways, so what this capability authoring is doing is it's just adding a couple of components onto here. So I'll get to this hit buffer element in a second, but so we're adding a casting entity, and this is something that I'm only going to be using later at the end of the this little presentation here. But you can use this. All this is just a reference to the entity that actually casted this capability. And that's so like you can, reference back if you ever need to like look at anything on the original entity or, give some power ups to that entity, which I'll be showing later. So the other thing that I'm adding is the entity team. So that way, whichever entity casted it, say if you are on the red team, we can add that entity team to it. And again, we can kind of like ignore friendly fire with that and make sure that we're only damaging people on the other team. So I'm actually assigning that entity team directly to the capability. Again, if we wanted, we could use this casting entity and kind of look back and see the team of the entity that casted it. But I think it's better to just have it on the actual entity itself. And I'm pretty sure that this enum value is just a single byte data, so it doesn't take up a lot of memory at all. Now, the important thing is this hit buffer element. So this is a dynamic buffer that I'm adding here. And so this dynamic buffer has 4 different variables in here. So you see that there is a public bool for is handled. The purpose of this is when we actually go through this hit buffer, I should probably explain what the purpose of the hit buffer is. So the hit buffer is anytime one of these capabilities actually collides with another entity, then it's going to add some data about that collision, or really a trigger, but I'm saying collision just because that's kind of, basically what we're doing is we're having 2 things collide together. So we can just kind of store some data about that collision event. So we're, storing some data about the entity that was hit. We're also looking at the position of the entity, and then we're looking, we can store a reference to the normal, so kind of like the angle between the, capability hitting a player. And the reason for that is we can implement some type of like knockback if we wanted to. So if we know that angle, then we know which direction that we can knock the different entities in. So that's kind of goes into what I was mentioning at the beginning about, adding in your own physics behavior. So it's kind of good to have that kind of normal, which essentially is just the direction between the two entities. And then finally, we have the public bool is handled. And the purpose of this is because this hit buffer is going to be continually populating with entities that it collides with. And we want to have this is handled in there to make sure that we're not, applying damage to something multiple times. So if we have, this trigger volume kind of passing through an entity, on each frame that capability is kind of overlapping that entity, we don't want to apply damage every single frame. We just want to apply damage one time. So it basically hits that hit buffer, and then the first frame we actually do all the interesting and important work on there, and then at the end of the frame we'll set the is handled to true, and then as it continues to pass through that, then we can check through our hit buffer just to make sure we're not applying things multiple times. So that's basically all that's set up on the entity right now. So now let's go ahead and make this capability move. So as you can imagine, if we just go over to our prefabs and we have this guy already selected, we can just add a component. And so I have a capability move speed authoring, and we can just pass in a move speed of 10. So I'll just give you a quick demonstration of what this looks like in practice. So you can see if we move over here, we can actually go ahead and fire this projectile off into the world. And then right now, we actually are not doing anything with like dealing damage or anything like that. But this just gives you kind of an idea about, we can just kind of add some type of data to this to make things happen. And then I have this guy just kind of firing things off right here, because eventually we're going to be taking damage as well. And I want to show a couple things off with that. So the way that this works, pretty basic stuff, but if we go to the capability components, you see that we have just a move to target. Nope, wrong one. That's later on. Capability move speed, which just has a value, and then there should just be a move forward. Anyways, it's just pretty basic stuff about it just moves the entity forward by that particular speed. You can check the source code on that if you really want to see that. So at this point, it's still kind of populating that hit buffer that I was just showing, but it's not really doing anything with it. So let me show you kind of how we're actually populating that buffer and detecting these collisions, or triggers rather, I should say. So I have this detect capability target system. So this is updating in the physics system group. Again, this is updating on the fixed time step. So it's not necessarily tied with the frame rate, but it's tied with a fixed time step. And then this is kind of the preferred place, I believe, to detect trigger events is after the physics simulation group has been completed, but still in the physics system group. So anyways, actually this is not even the right one that I want to look at. This is something later, but same thing applies. So detect capability trigger system. So yeah. Physics system group after physics simulation. So this is detect capability trigger. So all that's happening is inside the on update is we're just scheduling this detect capability trigger job, which is an iTrigger events job. The idea with these is, again, like we mentioned back in Unity, when I have this set to raise trigger events, anytime that that trigger volume overlaps another collider / rigid body, then one of these trigger events is going to be essentially raised. Now, this trigger event, from this, we don't get a whole lot of, exact information. So we do kind of need to figure some things out on our own. So basically what we're doing here is we first need to figure out, which is the trigger entity and which is the hit entity. So, which one is the capability versus which one is the enemy character that we're trying to damage. So we can just do this by, looking at the components, because we know that our hit buffer or the trigger entity is going to have a hit buffer on it. And we know that the entity being damaged is going to have a hit points type on there. So again, we can just do some quick lookups with these component lookups and buffer lookups to determine which one is which. If there is some case where a trigger event is raised and we don't have exactly one entity with a hit buffer and the other entity has the current hit points, then we'll just return out of here, because we don't necessarily care about that case in this particular trigger event detection job. So after that, we this is kind of what I was saying about we want to determine if the hit entity is already added to the trigger entity's hit buffer. So what we can do is just kind of search through this hit buffer, and we can see if the hit entity is equal to the entity at that position. So again, we're just iterating through the hit buffer that we've already populated, and we see if there's an entity that we've already targeted in there. If there is, then we'll just go ahead and return out of here, because we don't, again, want to add that entity twice in there. So next up, then, unfortunately with the trigger events, we don't get good information about the exact position of the, where the two entities are kind of overlapping. With the collision events, we do, and I suppose that's just kind of the difference between how triggers work versus collisions. So we kind of have to do just a little bit of estimating. So basically all that I'm doing here is just looking at the central position of the trigger entity and the hit entity, and then just kind of getting the midpoint between those, and I'm calling that the hit position, and then just doing a little bit of math on the hit normal. And here I'm using that normalized safe.
Because they can be at the same point.
Technically they could, yeah.
Yeah, so that's a good use.
Yeah, and then in that case, I don't care if the hit normal is just the identity, because that's fine if it's just at a 0 rotation for my use cases. So anyways, we just go ahead and populate this hit buffer element, we add a new element to the dynamic buffer, and you see that we just populate this with the is handled by default set to false. We pass in our hit entity, our hit position, and the hit normal, and then just go ahead and add that to the buffer. So now again, we're populating this dynamic buffer, and at this point, basically you'll see what happens if we come back here and enter play mode. And then actually I'm going to disable this guy for just a moment. Nope, not the player, the enemy, just so it'll be easier to find the capabilities that I spawn off. So when it passes through these 3 guys, we'll pause it and we'll come over here and we can select this, and then we can go down to our hit buffer. And then you can see that we actually have 4 entities listed in here. So one is the player, so it actually does collide with the player to begin with. So we do just always need to keep that in mind, that it is going to be colliding with our player when we spawn it from within inside the player. And then you see we have 3 other entries for the other 3 entities that this passed through, and it just keeps a reference to the position and normal of where that position or where that collision took place. Now you'll see that is handled is set to true, and that is because if we go over to that's an empty file. I moved it over to capability systems, and this last one that I have here. So I'm updating, I have this capability system group here that I've created, and basically everything that's kind of related to handling things related to the capability system is all going to happen within this system group here. And we can go into this and you'll see that this updates in the simulation system group. We'll update it after the fixed step transform or the fixed step simulation system group, as well as the transform system group. So we want to just make sure that these things both have been completed before we start doing any of our crazy capability stuff. So you'll see that this handle hit buffer system, I have this set to order last equal to true. Basically all this is doing is it's going through all these hit buffers, and it just sets is handled equal to true. So that way when we have our systems that we're going to get into just after this, again, those only run one time. So this is just, so basically what's going to happen is, for that first frame of that collision, is handled is set to false. Then we can run our extra logic about applying damage and everything like that. And then at the end of the frame, or the end of the group more specifically, we'll set that is handled to true, so that next frame comes around and we don't apply that again. Yeah. So anyways, we can, I'll just re-enable this guy here for now, and we'll come back to this prefab. So now let's actually go ahead and start dealing damage. So we have a damage on trigger authoring. So we can set the damage on trigger, we'll say set this to a value of 15. And then damage type, this is the exact same as from the previous one that I did on the damage, the previous showcase that I did on the damage system. So we can just set, say, physical damage for this, because I'm not doing anything special with damage types or anything like that. So now you'll see that when we go here, we can actually go ahead and deal damage to each of these entities as it passes through. So the way that this works is, let me see if there's actually anything interesting in the damage on trigger authoring. Nope, all we're doing is just adding this damage on trigger component. So you see the damage on trigger component, again, just has the hit points and damage type that we're using. So now coming into our capability systems, we'll find the damage on trigger system. So you see what this does is we basically have nested for each loops here. So the first thing that we're doing is we're querying for anything with that dynamic buffer of the hit buffer elements. It also has that damage on trigger, which we just used, as well as the entity team, again, to set that in the damage buffer. So this kind of gets into some of the things that we did last week, but once we have the hit buffer, so we're looking through the entire hit buffer every frame. So again, when we kind of shoot that capability through the 3 entities, this hit buffer is going to be 4 elements long, 1 for the player, 1 for each of the 3 entities. And then here's where we just check, if hit.is handled, we just continue to the next one, because again, we only want to do this once. And then here is where we actually add an element to our damage buffer. And this gets into the things that I was doing in the previous week, where we add to this damage buffer, and then we have a separate system that goes through that damage buffer, which actually applies the damage. So go reference that video if you want a little bit more information about what's going on that. But you can see it's really simple. We just make sure that, if the hit hasn't already been handled, just add a damage element there. So that's pretty easy to do. So next thing, we'll come back over here and let me get my notes and see what was the next thing that I wanted to show off here. Right, so the next thing is you'll see that, these capabilities, they basically just kind of go off into infinity and they just kind of, go forever. So we probably would want these to actually clean up at some point. So what we can do is just go ahead and add in a destroy on timer, and then we can set this to say a value of 5 seconds. And then, so now if we come back into play mode here, I'll just scoot back a little bit, go ahead and fire this off. And after 5 seconds, we should just see this capability disappear, and it does. And so this is, pretty basic stuff. It's not destroy on timer. It should be a destroy on timer system right here. So basically, yeah, as you can imagine, this is just decrementing the timer. Once the timer is less than 0, we just add the destroy entity tag to it. So this just kind of, showcases how we can easily add, new features to the different capabilities to, clean them up after some certain period of time. Where I think things start to get a little bit more relevant to, what we're doing with the combat system is if we come back to, we're on this guy here, we can add the destroy after hits authoring. So what this means is if we say set this to destroy after hits 1, that means that now, so you see if we shoot this off into the distance, you'll see that again it just gets cleaned up on time. But now if we shoot the entity, then it will destroy the first time that it hits an entity like this. And then if we go and say destroy after hits 2, then when we shoot this, it'll go through the first one and then hit the second one and get destroyed on the second one there. So the way that this works is destroy after hits. You can see that again, we're just iterating through everything with the hit buffer. We're looking through everything in the hit buffer. Again, we're just checking, if the hit has already been handled, just continue. We're making sure that we're ignoring any entity that's on the same team as us. Another way you could do this is to see if the hit entity is equal to the casting entity. If you maybe still want this to be affected by friendly fire, and then you just set the destroy after hits, just decrement that by 1, and then if it is equal to or below 0, then we'll just add the destroy entity tag to that. So pretty easy stuff, but still kind of a nice flexibility thing for us to have there. So this is kind of looking, a little bit bland at this point. We just kind of have things disappearing. So we can do, maybe a little bit more fun things where we can actually say spawn a game object. We'll say spawn a game object on hit. So we'll add this to the capability. And then, so we have a game object here under prefabs, which is the on hit effects. So what this is going to do is this now going to spawn some effects into our world anytime that the capability hits something. So you can see, you get a little sound effect here, and we just have a quick little particle system just kind of play. I don't know how well you can see that through the video, but you can see that, whenever we hit, it just, spawns that into the world. And so the way that this happens is we have spawn game object on hit, and as you can imagine, we go through the hit buffer. If it's already been handled, continue out of there. Again, we don't want to spawn this if it's on the same team. And then here we're actually using our spawn position. We're setting the spawn position equal to that hit position. So you can kind of see, I don't know how well you'll be able to see this here, but maybe if we zoom in on this a little bit here, that if we're kind of on this side, then the particle system kind of spawns on this side, whereas if we're on this side, the particle system kind of spawns on that side. Again, it's not super obvious at this type of scale, but again, we're just spawning it at the actual position that it hit, or the estimated position, I suppose I should say. And then also we can just get the spawn rotation by looking at our hit.normal, and I'm just doing a quaternion.euler on that. And then we just do a regular, unity object.instantiate, and we just have a reference to this spawn game objects on hit.value, which is, of course, is just a managed iComponent data where we're just storing that game object prefab. So we just, spawn that at the position and rotation. And then, of course, as you can imagine, this on hit effects is just a regular game object with a particle system, an audio source, and then I have a mono behavior to clean it up after 2 seconds. So
makes sense.
Sweet. And then, so then now we can take this a little bit further, and let's go to our enemy prefab. And our enemies can kind of act the same way that our capabilities can, where we can add, a lot of these similar things to it. So we'll go ahead and say spawn game object on destroy, and we can go ahead and add the explosion effects on destroy effects is what it's called. Let's go ahead and add this to our player as well. So we'll go ahead and spawn game object on destroy and add the, almost did it again, on destroy effects right there. Nope. Got it. So now when we come over here, you see that when we hit, we just get the, small sound, small particle effects happening. And then, so this time is actually going to destroy them. And we get a bigger sound and a bigger explosion there. So now let's go over to here. You can see that when our player dies, explodes. But, the game is still kind of going on at this point. So typically in a game, when the player dies, we would want some kind of like event to happen. Maybe we go to like a game over screen, or the player respawns. But we probably typically want like some event thing to happen for specifically when the player dies. So luckily I've thought of that, and we can go ahead and add a it's a game over on destroy. So this just adds a game over on destroy tag here, and then when we actually go and destroy it, we can look at this tag to do some fun events. So we will come over here, we'll get destroyed by this guy here.
Of course.
So we can get the Dark Souls "You Died" screen there. So the way that this works is, let's go to the destroy entity system. So you can see that, if the system API.has component game over on destroy, we'll go ahead and create this new game over entity and add a game over tag to it. So that's all it's doing, is it's just adding this new game over tag. And then of course we have a game over system, which has the require for update of the game over tag. And then all this does is it removes the game playing tag, and then also triggers this show game over UI, which is just a regular Unity UI feature. I should point out that when I remove this game playing tag, you can kind of see that we'll go over here. So this guy's just, constantly shooting shots out into the world. But then when the player dies, it stops. And the purpose of that, the reason it does that is because the system that I have that has it constantly spawning these shots has a require for update of this game playing tag. So, you could have this in maybe like your input systems if you want the player to, stop, sending input commands after it's died. You can have like a game playing tag and just remove that when the player dies. So that's looking good there. Okay, so the next thing that we can showcase is, spawning other things in the game object or in the scene here. So we'll go back to our, actually we'll do this on the enemy. So we can also spawn entities when we destroy. So we have an explosion prefab here. So now we can go ahead and kill these, and you see that an actual explosion kind of spawns in place. And this is actually going to deal damage to me. So if I'm close enough... Nope. Why did it not go? Oh, I didn't add it to the prefab, that's why. So now if I'm close enough, you can see that it took away like half my health, and then... So yeah, now we can use the capability system to now like spawn new capabilities. So we can say go to this explosion prefab, and this explosion prefab has, all sorts of things on here. You can see that this is applying, 50 magic damage to us. It's going to destroy on the timer. It has that same thing. It has its on hit effects. If we want, we could say even add like a, capability move speed. So we could like move this explosion. So what happens if we do this? Let's come over here. So you can see the explosion kind of moves. So you can kind of have those like different effects, or maybe the explosion grows or moves, because it's all built off of this same capability system. There are all these kind of basic building blocks which can all be interchanged and used with each other. So this is, where things start to get really fun, where you can really kind of empower your designers to do, all sorts of crazy things with this here. So other couple options that we could have is maybe come back to our normal projectile. Maybe we want to actually swap out the regular move system for a different one, where we're saying move to target. So let's set the move speed and radius to 10 on here. So you see now when we come back, the way that I have this set up is it's going to go forward into the world until it detects a close by entity. And then it'll actually go to that entity, and you see that it's glitching out. It's not actually cleaning those up right away. It's still cleaning them up after time, because I have destroy after hits set to 2. So if we just change that back to 1, now it should be destroy right away. And then same thing, these are going to be affecting us. So these guys are going to start chasing us now too.
Oof. Get good.
Get good. I know. So yeah, those are kind of like some of the main things that we can do. And also I just wanted to showcase that, we can also do things rather than, on trigger, like on collision, we can do things on use. So for example, we can go to this here and we'll say, heal on use authoring. So we'll say, heal ourselves by 10 hit points. So now if we come back over to here, we'll get damaged a couple times. Okay, I didn't die right there. So now whenever we actually cast this, you'll see that my health bar actually goes up now. I'm replenishing health because I have that heal on use tag set up on there. So just to give you a quick overview about how this heal on use works. So in our capability system, we have the heal on use system. And so all this does is... so again, yeah, heal on use, and we're only looking at the casting entity. We don't need to like iterate through the buffer or anything. We're basically just doing this heal on use in the first frame. And the way that we do that is by doing the actual work, and then at the end we just remove the heal on use component, and that way the system no longer runs on that particular entity. Of course, we could use like maybe an enableable component if we wanted to here, and just like save on not having to do the structural change. But anyways, you can see that all we're doing is hooking into that damage system that I showcased in the previous episode of the Hot Path show, and then here we're setting the damage type to a damage type of healing, and then just setting the hit points and damage team on here. So again, hooks right into the damage system from last week or the week prior. And then I think that's pretty much most of what I wanted to showcase. I think the only other thing that I didn't specifically show off was how the move capability to target system works. So actually, this is kind of one of the interesting things that I use, for the capability system, and just kind of like ECS in general. I kind of have like multiple like systems kind of separated out into like multiple things that can kind of run one after the other sequentially. So this one here is the detect capability target system. So this is essentially going to run, earlier on in the frame, or this actually runs in the physics system group, to actually detect this, trigger between, or this overlap, I guess is what I'm using, between the targeting radius and other entities that we are potentially going to be targeting. So this section, all it does is it finds that target entity. Once we have the target entity, then we can move towards it in another system. So this is kind of the detection system. We have the collision filter, so we just are belonging to this raycast layer that I have set up, and then we're colliding with any characters. And then you can see inside the on update, what I'm doing here is I'm using the collision world, and I can do this overlap sphere. I have this at the transform.position, so this is running on the entity that's like trying to look for a target. So if we shoot a shot out into the world, it's running on that shot. So it's always going to be doing this overlap sphere origin from like the center of that entity. And then we're going to go out, search through that detection radius, which we've defined in the move to target component. You see that we have a move speed and detection radius here, as well as the actual target entity. So once we do that, we can just figure out which entity is actually the closest entity. And then once we have the closest entity, then we can actually just set the target entity on here. So again, this just detects that target entity exists. And then we actually have a move capability to target system. And then so what this does is it just runs now on that with the move to target. And then all we're doing here is we're just checking to see if the target entity is actually set. And we can do this by using the transform lookup.try get component. So basically this is kind of like a way that I'm doing kind of like two things in one here, because we will need the transform of the target entity to figure out where it is. However, if this basically returns false, maybe if the entity is equal to entity.null, then this actually doesn't run here. So what's happening in this case is, if we do have that, target position, we can figure out the direction to the target and then use the quaternion dot look rotation safe, and then passing in that to target direction, and I have the math.up as my other vector. Yeah. So basically this is just kind of like orienting the shot towards the target, and then we're just going to be moving it forward after that. So basically, if there's no target, it's just going to move forward. If there is a target, it's first going to rotate towards the target and then move forward, if that makes sense. So anyways, that is basically kind of the showcase that I have for the capability system here. I think it's a really fun system. Tobias, before we get into any questions and comments from the audience, do you have any questions or comments on this? Anything else that you might want to see?
Yeah, I have actually two things. I'm hearing myself. Is it something on your end or is it on my
I'm
end?
not hearing you double, so.
Well, it's a little bit tricky to speak for myself. Let's
Oh,
see if I can.
here, wait.
Oh yeah, that's much. No, I still hear myself. Uh, we hear him double. Is there
Oh,
something on
really?
my end? Uh,
Oh, I
uh,
know why.
I think you had stuff from your
Wait,
screen
hold
share.
on. Okay.
Yeah. Okay. There we go. Yeah, there we go. But
Okay. Because I was
you can
sharing my
probably.
screen audio because I wanted the the sweet Dark Souls effects to come through. So let
Yeah,
me share my
and
screen, but not share audio this time.
yes, because I want to point one thing out on in your code. Uh, so can you go to the place where you set is handled?
So yes,
Yes. So you see there your 3 lines of code which handles the is handled thing.
yes.
Yes. So I did the exact same thing you did until like half a year ago, maybe a year ago, which I found out there's another way of doing it in one line. I think it should be completely possible with dynamic buffer too. So if you take a new line before you declare the hit variable, before like right line 59, and you
This here.
do hit buffer I, and then you do try if there's a element at. No, okay, so as array, just do as array first. Oh, isn't that? Oh
It's
no, it's
hit
the
buffer.
whole
Yeah.
hit buffer. But try
Wait,
no
so are
no
you saying hit buffer dot element at
yeah, and
I?
then I, and then dot handled. So no equal dot handled is handled, and then true.
I knew there was another way to do this.
So element at returns a reference to it, not the copy.
Right.
Yeah. I discovered that one, and I'm like, oh, so much code on
I'm
my
glad you
code
caught that.
cleaned
I'm
up.
glad you caught that because I was probably going to ask you about that later, anyways.
Yeah. And so that was just a small thing that I realized because I have the same picking out the element and then setting something and then pushing it back again. I had it all over the place before. Yeah. Oh, I can see somebody really having a like me. Yes.
Yeah, and let me bring back the code that I had previously. So I basically extracted out the hit from the hit buffer, set is handled equal to true, and then I had to set that back in the hit buffer.
Go to the definition of element at just so we can see what's going on there. Yeah. So ref, that's
Check
the
write
trick.
access, return bounds, ref unsafe utility, array elements as ref, t buffer header, get element pointer, m buffer index. Interesting.
Complex stuff, but the ref thing in the return t
Yeah.
in the declaration, the line 202.
Oh
That's
yeah.
that's that's the sweet thing. Yeah. All right.
Nice.
So yeah, I'm glad that the
It
more
gets
more than
reference to the
more than
element.
me was stuck on the old one for a long while. When I discovered that, I was like, why didn't I realize that? But you learn, you learn, you live, you learn. Maybe that's the way around. Another thing, which is more of a philosophical thing, which is you mentioned that this way of dealing with this was very like you have building blocks, and it's the first time you showed me this too, and I'm like, yeah, it's very neat building blocks thing, the way you unfolded all of the feature set and everything, and like for designing and for most games, that's a very very good way of dealing with it. I wanted to point out like a counterweight, and this is not wrong or right in any
No,
way,
please,
shape,
please.
or
I want to
form.
hear it.
It's
Yeah.
just a counterweight. So I have in just read instructions with all of the powerful weapons and a lot of enemies. I have a situation where I might hit like 50 enemies in the same frame with 50 different bullets, and all of these bullets hit distinct enemies, and they have like effects, damage, some other secondary thing that happens, and then like sound effects and all of that, and that like bullet bullet hole decal, or like bullet hole things. All there's like a cascade of different things that happens with every hit. And I had similar, not as good like building Lego wise as you had, but I have a similar situation. But I had just too much to be able to do it with entities. It just was just creating and destroying and keeping all of these data onto entities was causing too much of a hiccup to creating and destroying and doing structural changes.
Mm.
So my system is like not at all as flexible, but it's like no entities involved anywhere basically. And that's
Mm.
something that I plan to show off sometime, maybe in 2 3 4 weeks on this show,
Yeah, yeah, that'd be
like
awesome.
how I deal with the, because there's like entities makes it very easy to build on top of it, and it's like very very nicely integrated, obviously the whole ECS. But you can do this type of stuff less flexible but faster if you just do straight up arrays everywhere and nothing, because sometimes you don't care about like a entity that you can like address or something. You just care that there's data, and just go through a buffer data, and it's just,
Right.
you don't need to have any individuality between data. You just like, oh, there's damage and there's more damage and there's damage and there's effects, and that's it. And that's so that's a counterbalanced like flexibility or performance. And this is still performance. This is
Yeah,
like
yeah, yeah.
way
No,
more
the
than
performance is
most.
still, yeah,
Yeah,
great on here, but yeah, no, I totally get what you're saying, and I guess it kind of depends on like the type of game that you're making. Like this type of thing lends itself well towards games where maybe you have like really in-depth like skill upgrade trees and everything like that, where you can like, you know, as you level up, you can kind of like modify your weapons, and you can swap out between weapons on the fly,
yeah,
and continually be upgrading things and kind of like lead into that loop. I'll tell you, I think one thing that I want to do for a future episode probably won't be for quite a while, because I know we have a bunch of other topics that we want to get to before then. But I kind of want to show how this would be integrated with like an actual like skill tree, where you could like have some kind of like user interface to because most of the stuff that I'm showcasing here is like how to modify these things through the editor, which is great for developing and everything like that. But in a mature product, you would want this to actually be kind of exposed to the user in some sort of way, where maybe they can like purchase upgrades, and then that actually
yeah,
like builds up these capabilities in the different ways. And just like how do we handle that and manipulate the prefabs and everything. And there's a lot of kind of like interesting things that you need to consider when you get into that. So that's
yeah.
again something that I would like to kind of tackle down the line. But yeah, I mean, it totally makes sense. Again, if you don't have like the need for that type of complexity of like adding these little things and doing a bunch of fine manipulation and all that, that you just use like the raw memory arrays and everything.
I think there's a lot of people coming into dots who like think of like, oh, and ECS is like a very nice fast system, and it is, but like for me, once I realized that a lot of the data that you're shoving around in a typical game don't need to be individually addressable, which is like one of the purposes of entities, right? So you can address a specific entity. If they don't need to be individually addressable and they live and die pretty quickly, then you're like, when you just see an example of how you can do it, yeah, I think it's like a sort of a flip in. So I hopefully we can have some few example of that one in the future, and like show off how it's like really just data and nothing else, just exactly what you need and no fluff around it, and it's like a C++ all over again or something.
Yeah, yeah, yeah. I would love to
Yeah.
check out what you got. Yeah, any other related things to maybe your combat system or anything like that, or should we get into some of the questions that we have?
No, a lot of the concepts and stuff are similar to how I did it. Like the piercing, like you have like hits counting down and then death and stuff. All of those stuff. I have also similar thing. I've solved it in a very similar way, and I just thought it was a solid. Just that's how it would look if I didn't have 4,000 enemies. Then I would probably be still on the entity solution and not be forced to do it without entity. So yeah, looks good.